Hi everyone, we the students of Weltech University are here to present our project, that is Autonomous Traffic Sign Detection and Recognition in Real Time. Now we're gonna discuss in detail the breakdown of our project, and before that I'm gonna introduce ourselves. The members of this project are N. Malarvizi ma'am, Atreya Kalyan, Manikanta and Krishna Dheeraj. We are grateful to our Weltech University for giving this opportunity to showcase our abilities. So coming to this project, we are here to discuss the issue behind this project. So over recent years, there is a huge increase in road accidents, which make us to take the surveillance actions to reduce road accidents. In recent, due to researchers, there is a huge improvement in field of deep learning and artificial intelligence. Our project is mainly working in traffic signs detection and classification for drivers in real time. We built the model with the help of convolution neural networks as a subfield of deep learning and artificial intelligence. We collected traffic signs dataset from Indian and German road signs, which are around 20,000 images. We are developing a learning model with Keras framework, which is high level API. The Keras work on the TensorFlow backend, which is developed by Google. The Keras framework enables us to build a state-of-art model to detect the road signs. In developing the model and to pre-process the images, and the images we are used in Python language, which has a vast number of libraries for images computation and build deep neural networks. The main aim of the project is to develop traffic signs detection and classification for drivers, which help us to improve road safety. Our project will also help new learners to improve their driving skills. Objectives. Aim of the project is to develop a model for road traffic signs detection and classification for the drivers to provide a visual and sound alert to the drivers. The scope of the project is to reduce the chance of the accident, to remain good attention and road while driving. Introduction. Our project is aimed at developing a vision-based system for drivers. We use technology like deep learning, computer vision, Python to build this. Our project model will be able to identify 32 different signs, and we took a database of 20,000 plus images which has been collected from German road signs. We used Keras to build the model. Since Keras is providing vast number of features, it enables us to build a state of the model which will detect road signs with accuracy of 90%, and we used PyCharm IDE, which is a part of Anaconda software. We used convolutional neural networks to build this model. Coming to literature review, initially in 2011, Zachlota, Stanislavski and Hamden, they made traffic signs classification using KD trees and random forest. So from them, we used the German traffic signs benchmark dataset containing 43 classes and more than 50,000 images. And then we combined the trees classifiers with HOG descriptors as well, and achieved classification rates up to 97% and 81.8% respectively. And in 2012, Greenhalgh and Mirmedi has made real-time detection and recognition of road traffic signs. In this proposed system detects candidate regions as maximally stable extremal regions, which offers robustness to variations in lighting conditions. Later in 2016, Yusuf, Albani, Nardi and Bloisi has made fast traffic sign recognition using color segmentation and deep convolutional networks. And later in March 2020, Esko Lehtinen, Neha Malhotra, Nicola Starkey and Samuel Carlton has made speedometer monitoring while driving with a speed warning system. This indicates the speed warnings re-engage the drivers to cognitive control of speed, which they may have memorably lost before speeding. So now we're going to discuss about the design and methodologies of this project. The suggested system uses CNN algorithm to detect and recognize traffic signs. Pre-processing of this input is done before classification to remove noise and reduce complexity. We use technologies like deep learning, computer vision, and Python to build this application. The proposed TSDR model will be able to detect 32 different road signs. We trained a model with 20,000 images which has been collected from German and Indian road sign dataset. We used Keras to build a model as Keras provides vast number of features which enable us to build the state of the model that will detect road signs with accuracy above 90%. So this is the detailed flow of processes in traffic signs detection and recognition. Coming to Pi camera, it is a compact lightweight camera that bolsters the pre-processing of the image. It is mostly used in AI or observation ventures. It is regularly utilized in observation rambles. The payload of the camera is smaller amount. Apart from this, Pi can likewise utilized in typical USB webcams that are utilized along the PC. Grayscaling. It is a process of converting an image from other color spaces. For example, RGB, that is the scales of red, green, blue, and also HSV is used to the shades of gray. Histogram equalization. This image processing technique used in the histogram of the input image to modify the contrast of the image. It stretches out the intensity range of the input image to improve the image's contrast and equalizes the image. Image validation. Image compliance collects the validated data so it can apply the specific data set of an image validation rules, which allows the rule dataset to execute the same image test using different threshold criteria and validate. Image recognition. Speed limits, prohibited entry, traffic signals, turn left or right, children's crossing, no passing of big trucks, and so on are all the examples of traffic signs. The technique of determining which classes a traffic signs belong is to know the traffic sign recognition. Steps for the traffic signs detection and recognition model. The first step is data collection. The road signs data has been collected from German and Indian road signs dataset. The dataset consists of 20,000 images of different road signs. There are 32 different road signs that are similar to Indian road signs in 30 classes. So we made our prediction with 32 different road signs as shown. Coming to pre-processing of data. The images are resized into 32 into 32 pixels. The images are then converted into grayscale and histogram equalization, and then the images is given to the model for texting. Splitting of training and testing data. The imported data set of images is separated into the training, validation, testing. The distribution of training dataset as number of images used in each class of different traffic sign. For training, we took 16,472 images with 32 into 32 pixels and with 3 layers, which is RGB. For validation, we took 4,119 images with 32 pixel and 3 layers. For testing, we took 5,148 images with 32 into 32 pixels and with 3 layers. Model creation and selection. The model is trained with the training data set for 10 times. The training images have divided into batches with 50 images each batch. The proposed model has 11 layers of network and 32 layers node with predict 32 different classes of road signs. Validation of model on testing data. Once the model is created, it has been validated by extracting the image path with corresponding labels. Next is to resize our images to 32 into 32 pixels to predict the model. Next is deployment of selected model. The recognition network is trained on the cropped image part of the dataset to identify different road signs in an image. Finally, prediction of output. The model can detect 32 different types of road signs, which will make the system more efficient. Coming to results and discussion. The input, design and trained pickle model is shown in the figure. The image will be sent through the model to predict the output, and along with the collected image, the model output will also be sent to the further process to alert the driver with LCD display and recognize the signs. For the purpose of demonstration, we have used PyCharm software and we have used Python 3.7 for the computation process. As you can see in the images, the model has 99% accuracy. The system will easily integrate with other hardware equipments. In that figures, you can see that it dissipates the ahead only and stop sign. The model predicted the class of the road sign and probability of the model. Finally, coming to the conclusion and future enhancements. The proposed traffic signs detection and recognition model is able to predict 32 different type of road signs, which is helpful to the implement the real world. The model can integrate with other equipment to use it effectively. The model has gained an accuracy of 0.9965. We can actually improve this model to make more predictions on new road signs with reduced in error by training the model with huge amount of data. The model can be further improved to make suitable for all types of vehicles. So these are the references that we took to enhance this model.